Steel breathes in the thin mountain air, a slow, cavernous inhalation that rattles loose stones from the slope. At dawn, the excavator's shadow stretches across the valley like a moving cliff, blotting out the sun in measured increments. 6,000 tons of riveted iron and cast steel settle onto their tracks, and the ground answers with a low animal groan. Boilers thrum, gears engage. A ladder of buckets, each large enough to swallow a truck, begins its rotation, teeth biting into ancient rock with deliberate violence. Men stand beneath it, reduced to silhouettes against the machine's flank. Their helmets shine briefly, then disappear under falling dust. A signal whistle cuts through the roar. The excavator advances. With every meter gained, the mountain loses centuries. Granite fractures along fault lines no human eye ever mapped. And trees topple as if uprooted by a tide. The air fills with pulverized stone, sharp on the tongue, burning in the lungs. This is not excavation, it is erasure. Inside the control house, gauges tremble at the edge of their tolerances. Needles hover near red. The operator's hands are steady, but the machine is never still. It shudders, flexes, complains. Rivets heat and cool in cycles measured in seconds. Somewhere deep in the superstructure, a hairline crack opens, then closes again, unseen, unrecorded. At the base of the cut, a worker stumbles as the ground shifts underfoot. He looks up. The bucket wheel passes overhead, close enough to strip the air from his chest. A single bolt shears with a sound like a gunshot, lost in the thunder. No one hears it. The machine keeps moving. By nightfall, the mountain is wounded beyond recognition. By morning, something essential will have changed. Within the steel, within the men, within the valley itself. And long after the excavator falls silent, after its tracks rust into the earth and its name is struck from ledgers, the damage it began will continue, patient and irreversible. Its designers called it inevitable. That was the word used in memoranda, speeches, and blueprints stamped with official seals. The excavator was not merely a machine, but a conclusion, the physical answer to years of stalled production and rising demand. Mountains blocked access to coal, ore, and strategic stone, and delay carried measurable cost. Smaller machines failed. Manual labor stalled. Rail schedules collapsed under shortages. In that arithmetic, scale appeared as salvation. If resistance was geological, then force must be continental. And 6,000 tons became not excess, but necessity, justified line by line, calculation by calculation, until mass itself was treated as a virtue rather than a risk. It promised certainty where hesitation had failed, and silence where argument once consumed committees and calendars across ministries, ledgers, and production offices. The paradox lay buried inside the logic that birthed it. To overcome nature, the machine had to embody nature's own indifference to fragility. Weight was protection. Redundancy was survival. Every component was oversized, every margin thickened, every joint reinforced against forces no prior excavator had endured. Yet the same mass that granted dominance multiplied consequence. Momentum could not be halted gently. Stress had nowhere to escape. Failure, when it came, would not arrive as a crack or a pause, but as an event. The engineers understood this in theory, even as they signed their names beneath the drawings. They trusted procedures, inspections, and discipline to domesticate scale, believing control could always be reapplied, no matter how vast the mechanism grew under pressure, under deadlines, under political and economic expectation itself. From the outside, the excavator projected certainty bordering on inevitability. It erased topography with measured patience, advancing meters per hour, thousands of tons per cycle. Progress charts climbed. Output reports silenced critics. Each completed cut became evidence that doubt was obsolete. The machine did what it was built to do, and it did so publicly, spectacularly, in full view of officials and financiers. Success, however, altered perception. What began as a solution hardened into an assumption. The excavator did not need to be questioned, only fed, maintained, and kept moving. In that shift, vigilance dulled, skepticism receded, and the boundary between calculated risk and accepted fate quietly dissolved inside boardrooms and control cabins alike, where authority carried weight and success insulated decisions from scrutiny through repetition, scale, and institutional confidence. This was the central paradox embedded in steel and stone. The excavator existed because failure elsewhere was unacceptable. Yet its existence ensured that any failure would be absolute. It could not be abandoned mid-cut, paused without consequence, or replaced without collapse of the system built around it. Everything bent toward its operation: labor schedules, rail lines, budgets, political promises. The mountain was no longer the only thing being carved. Commitment itself was reshaped, narrowed, and hardened until retreat became unthinkable and continuation became compulsory. In that condition, the question was no longer whether the machine was safe, but whether stopping it was even possible without destroying what depended upon it, including livelihoods, contracts, reputations, and the authority that approved its creation at the highest administrative and industrial levels globally. The mountains were not an abstraction on a map. They were physical impediments measured in gradients, strata, and resistance per cubic meter. Beneath them lay coal seams that powered furnaces, iron veins essential for steel, and stone required to expand cities already straining under population and industrial growth. Extraction targets were precise. Shortfalls were recorded weekly. Rail depots reported idle engines. Smelters cooled. Contracts tightened. In response, pressure flowed downward through bureaucracies and outward across landscapes, converting geology into an administrative problem that demanded resolution, not patience. The crisis was cumulative rather than sudden. Years of incremental demand had outpaced the methods designed to satisfy it. Traditional open-pit excavation reached its limits where slopes collapsed faster than they could be stabilized. Tunneling proved too slow, too labor-intensive, too vulnerable to flooding and collapse. Smaller mechanized excavators broke down under continuous load, their duty cycles exceeded by necessity rather than negligence. Each failure was documented, categorized, and ultimately dismissed as evidence that existing tools were insufficient for the scale now required. The mountains remained. Production quotas did not adjust to terrain. Terrain was expected to yield. Economic planners reframed delay as loss. Each uncut ridge became a deficit measured in currency and influence. Industrial rivals expanded capacity elsewhere, leveraging flatter ground and earlier investments. The pressure to compete transformed extraction into a strategic imperative. Ministries intervened, funding streams widened, time horizons shortened. What could once be approached cautiously was now accelerated by decree. In this environment, restraint acquired the appearance of sabotage, and caution was interpreted as institutional weakness rather than prudence. Political narratives adapted accordingly. Public statements emphasized progress, resilience, and mastery over natural limits. The mountains were described as obstacles to national momentum, relics of a landscape awaiting correction. Maps were redrawn to emphasize routes and resources rather than elevation. Geological surveys were repurposed into planning instruments, their warnings softened by optimistic margins. Risk assessments focused on output variance, not structural uncertainty. The question was no longer whether the mountains could be removed efficiently, but how quickly their removal could be demonstrated as proof of industrial resolve. Labor dynamics reflected the same compression of choice. Employment surged in extraction zones, drawing workers from agriculture and urban trades. Temporary settlements hardened into permanent camps. Wages rose, but so did dependency. Entire communities became tethered to output figures and supply schedules. When machinery failed, wages stalled. When access roads washed out, food shipments lagged. The mountain's resistance translated directly into human precarity, tightening the feedback loop between geological delay and social consequence. In that context, scale appeared as inevitability rather than ambition. The logic was recursive and self-reinforcing. If smaller machines failed, larger ones were required. If delays persisted, more force was justified. The mountains, unmoved by rhetoric or urgency, became symbols of defiance against a system unwilling to accept limits. Their continued presence sharpened the demand for a decisive intervention, something singular, overwhelming, and permanent. The excavator was conceived not as an experiment, but as an answer to a crisis that had exhausted alternatives, narrowed tolerance for uncertainty, and reframed domination of terrain as the only remaining path forward. The design phase did not begin with sketches, but with limits being erased. Conventional constraints, transport weight, assembly size, material fatigue thresholds, were treated as negotiable rather than fixed. Engineers were instructed to think in aggregates, not components. If a beam could not be forged in one piece, it would be joined. If a motor could not deliver sufficient torque, it would be multiplied. The guiding premise was simple and absolute. No single obstacle was allowed to dictate the machine's final form. The excavator would be designed outward from function, not inward from feasibility. Planning offices filled with layered drawings, each sheet adding mass, a length or redundancy. The bucket wheel alone required months of recalculation. Its diameter exceeded prior records by meters. Its teeth hardened to survive continuous contact with abrasive stone rather than soil. Load simulations assumed uninterrupted operation across shifts, weeks, and seasons. Duty cycles were extended on paper well beyond established norms, justified by conservative safety factors that accumulated into unprecedented thicknesses of steel. Weight climbed steadily, then sharply, until the number itself, 6,000 tons, ceased to shock and instead became a stabilizing reference point. Everything else was measured against it. The industrial apparatus required to build the excavator expanded in parallel. Foundries were retooled to cast larger sections. Rail spurs were reinforced to carry loads they were never intended to bear. Entire fabrication halls were reserved for single components, their floors braced and rebraced as tolerances tightened. Welding procedures were rewritten. Riveting teams worked in shifts measured not by hours, but by thermal cycles, waiting for metal to cool before stress could be redistributed safely. Precision was demanded at scales where precision had rarely been enforced before. Each success validated escalation. Prototype joints held under test loads. Bearings rotated within predicted tolerances. Power transmission models confirmed that, in theory, the excavator could move itself and its burden without tearing apart. Reports emphasized achievements. Setbacks were framed as refinements. And delays were absorbed into revised schedules that still promised delivery before shortages became politically visible. The machine advanced from concept to inevitability through accumulated proof, each milestone narrowing the space for descent. The rise was not merely technical, it was institutional. Departments aligned themselves with the project's success. Careers advanced alongside its progress. Suppliers expanded capacity on the assumption of follow-on orders. The excavator became a keystone investment, anchoring expectations across sectors that had little direct connection to excavation itself. To question its viability was to question the planning logic of an entire industrial moment, a step few were willing to take once commitments had hardened into contracts and public statements. When assembly began on site, scale achieved visibility. Sections arrived on specialized transport, their movement requiring road closures and reinforced bridges. Cranes were erected solely to lift other cranes. The excavator rose incrementally, its silhouette redefining the horizon long before it operated. Observers described it as a structure rather than a machine, something inhabited rather than operated. Control rooms were fitted with insulation, heating, and layered instrumentation more akin to a power station than an excavator cab. By the time the first test rotation of the bucket wheel was completed, the project had already succeeded in one respect. It had proven that such a machine could be built. That achievement alone altered expectations across the industry. If 6,000 tons could be mobilized and coordinated, then prior limits were no longer binding. The excavator stood as evidence that ambition, sufficiently resourced and shielded from doubt, could translate directly into steel. What remained untested was not its ability to move mountains, but whether the system that created it could withstand the consequences of doing so continuously, under pressure, without pause. The excavator was less a single machine than a coordinated assembly of systems bound together by motion and stress. Its mass was distributed deliberately, calculated to prevent localized overload while allowing continuous operation on uneven terrain. At its base, a tracked undercarriage stretched wider than a railway platform, spreading weight across hundreds of contact points. Each track link was forged thicker than those used on armored vehicles, pinned and bushed to tolerate constant vibration and shock. Beneath them, and the ground was compacted, reinforced, and monitored because even bedrock could shift when subjected to persistent asymmetrical load. Above the tracks rose the central superstructure, a lattice of girders arranged to resist torsion as much as compression. Power flowed upward from multiple boiler units, feeding steam turbines coupled to generators. Electricity, rather than direct mechanical linkage, drove much of the motion, allowing torque to be distributed across independent motors. This choice reduced immediate stress on shafts, but introduced dependence on cabling, insulation, and precise synchronization. Failure in one circuit could cascade through others, not explosively, but insidiously, degrading performance while remaining within nominal operating ranges. The bucket wheel dominated the machine's forward profile. Its rotation was slow by design, measured in revolutions per minute rather than speed. Each bucket engaged the mountain sequentially, cutting, lifting, and discharging material onto conveyor belts that ran the length of the excavator's body. These belts formed an internal artery system, carrying crushed rock toward waiting rail cars or spoil piles. Tensioners adjusted continuously, compensating for load variance and thermal expansion. Misalignment of even a few millimeters could shred a belt under full load, halting operation instantly. Structural redundancy was extensive, but not infinite. Bearings were oversized, yet finite. Gear teeth were hardened, yet still subject to fatigue. Lubrication systems operated under pressure, delivering oil through channels drilled deep into rotating assemblies. Blockage meant heat. Heat meant expansion. Expansion altered clearances calculated to tolerances that assumed ideal conditions. The machine functioned because those conditions were enforced relentlessly by maintenance crews working around the clock, listening for changes in pitch, feeling for vibration through gloves and boots. Control systems reflected the same balance between power and fragility. Gauges tracked temperature, pressure, and load across dozens of subsystems. Alarms existed, but thresholds were set high to avoid unnecessary stoppages. Operators learned to read patterns rather than indicators, sensing when the machine was approaching discomfort long before instruments confirmed it. Officially, everything was monitored. In practice, much depended on experience and intuition operating within narrow margins. At the excavator's engineering was impressive, precisely because it held together under forces that would have destroyed smaller machines outright. Yet its integrity relied on continuous equilibrium. It could tolerate immense load, but not imbalance. It could endure stress, but not surprise. Every component assumed that every other component would behave as expected. The giant did not forgive deviation. It absorbed it, redistributed it, and carried it forward, accumulating strain invisibly across steel that appeared unchanged from the outside, massive, confident, and deceptively stable. The flaw was never obvious. It was not a missing bolt, nor a cracked beam visible to casual inspection. It was a calculus of weight and repetition, a slow accumulation of micro-trauma imperceptible to human senses yet relentless in effect. In a structure 6,000 tons in mass, stress distributed unevenly through joints, girders, and bearing housings, creating points of invisible tension. Engineers recognized these vectors in theory, but in practice the enormity of the machine made monitoring them incomplete. The arithmetic of failure moved slower than motion, measured not in hours, but in weeks, months, the slow corrosion of iron under cyclic load. Rivets in the bucket wheel tower absorbed shocks beyond design thresholds with every meter of excavation. Gears flexed minutely, transferring energy along shafts that expanded and contracted under heat. Each cycle left a trace, each trace compounded the next. It was a quiet process, imperceptible in the day-to-day clamor of operation. Operators noticed subtle changes, a vibration slightly sharper, a note higher in the turbine's hum, a hydraulic hiss longer than usual. They logged it, noted it, and continued. Production schedules did not allow hesitation. Delay became more dangerous than risk. Thermal fatigue amplified structural vulnerability. Steam turbines generated heat unevenly. Some circuits ran hotter than others. Metal expanded, then contracted, creating micro-cracks in castings and welds. Lubrication masked friction until oil thinned or pooled in unexpected places. Bearings, oversized yet under continual load, began to wear asymmetrically. Each anomaly was small, benign in isolation, but multiplied across thousands of contact points, it became a systemic hazard. The giant moved as though invincible, yet beneath its surface, entropy was steadily gathering force. Design compromises also played a role. Most sections transported in multiple pieces required joints that, while engineered with redundancy, introduced weak points. Load distribution models assumed uniformity that never existed in practice. Rock density varied along the mountainside. Buckets occasionally struck harder veins. Gears absorbed shocks beyond theoretical loads. Repeated cycles accentuated asymmetry, feeding stress into components that had been designed to balance perfectly but could not adapt to irregularity. The flaw was invisible precisely because it was systemic. spread across the architecture of motion, embedded in the very principles that made the excavator extraordinary. Human oversight could only slow the inevitable. Maintenance crews performed inspections, replaced worn parts, adjusted alignments. Yet the scale of the machine exceeded the capacity of even the most rigorous schedules. Critical warning signs emerged at the periphery. Subtle deflection in beams, microfractures in high-stress zones, and slight lag in hydraulic response. Individually, they were almost meaningless. Together, they presaged catastrophe. The silent arithmetic of fatigue was not abstract. It was a physical ledger of stress, accumulating debt that no operator, no engineer could fully reconcile until the cost manifested in irreversible damage. And so the excavator continued to move mountains, confident, unstoppable, yet silently compromised. Its flaw was not a question of if, but of when, and the mountain it confronted was both adversary and witness, recording each imperceptible shift in metal, each moment of accumulated tension. Before the day arrived when history would force the invisible arithmetic into dramatic visibility, the men who operated, maintained, and endured the excavator existed in a world of perpetual scale. Their lives were measured not in hours or days, but in shifts that cycled with the machine's rhythm. Sleep was regimented around operational schedules, meals taken between inspections and maintenance runs. Noise was constant, steam hissing, chains grinding, gears clanging. Air was filled with fine dust, metallic tang, and the smell of heated oil. Breathing became a conscious act. Voices raised above the machine's roar were swallowed instantly. Conversation required proximity and repetition. Orders were repeated until understood. Silence was dangerous because it signified inattentiveness, and inattentiveness could cost life. At camps rose beside the excavation site, temporary at first, but gradually permanent. Rows of huts and barracks were pressed together to conserve heat and proximity to the machine. Water was scarce, fuel for heating scarce, medical facilities minimal. Injuries ranged from lacerations to fractures. Each carried risk amplified by scale. Even a simple slip under the tracked undercarriage could be fatal. The giant did not pause for human error. Yet life adapted. Men learned to move with the rhythm of steel, to anticipate its oscillations and subtle hesitations. Routine became instinct. Instinct became survival. Hierarchy was absolute. Foremen, supervisors, and engineers commanded attention and compliance. Their knowledge was the interface between man and machine. Operators relied on signals, schedules, and warnings, or understanding that the machine itself would not compensate for human mistake. Yet the human element persisted as both necessity and vulnerability. Each operator, each maintenance team member, bore responsibility for thousands of tons of motion. Fatigue, inattention, or misjudgment could ripple catastrophically. Training was rigorous. Apprentices shadowed veterans, absorbing the cadence, tension, and instinctive adjustments required to survive beneath moving mountains. Beyond the immediate danger, psychological strain persisted. Men witnessed the machine's destructive capacity daily. Entire slopes were reduced to rubble before eyes trained to measure and predict rock movement. Trees, animals, even streams vanished in measured cycles. The mind grew accustomed to annihilation at a grand scale. Yet the knowledge of fragile steel under immense stress introduced persistent anxiety. Operators reported dreams of cracking girders, falling buckets, and collapsing frameworks. Discipline was required not only for operation, but for mental endurance, an unspoken psychological contract linking life expectancy to attentiveness. Social life was compressed. Families often lived nearby, but visits were infrequent. Workers bonded around shared meals, brief recreation, and ritualized inspection procedures. Humor persisted in small, controlled doses, one way to temper constant tension. In rare moments, the men paused to observe the mountain receding beneath the machine, a silent acknowledgement of their role in both creation and destruction. They were, paradoxically, both masters and subjects of the steel colossus, living beneath it, repairing it, surviving it, and surrendering each day to its rhythm, where human scale was always subordinate to industrial scale. The machine defined their environment, their risk, their social order, and their perception of the landscape itself. It was omnipresent, omnipotent in function, and omnivorous in demand. The worker existed at the interface of scale, a human counterpoint to mechanical omnipotence, mediating between power and collapse, life and the ever-present possibility of irreversible failure. Every day beneath the excavator was both labor and endurance, a measured negotiation with steel, gravity, and history itself. Even the most experienced operators could feel the change before instruments recorded it. Vibrations altered subtly, carrying a tone previously absent, a frequency almost drowned in the machine's omnipresent roar. Bearings, at once smooth under load, began to chatter. Hydraulic pistons lagged by fractions of a second, imperceptible on casual inspection, but measurable across thousands of cycles. Each anomaly was a whisper of the mountain's resistance, a reminder that the forces being overcome were not neutralized, only absorbed, redistributed, and compounded. Maintenance logs began to show irregularities. Buckets chipped faster than predicted. Conveyor belts frayed along edges previously deemed low stress. Rivets showed micro-fatigue along the bucket wheel tower. Engineers calculated tolerances daily, adjusting lubrication schedules and alignment angles. Reports were annotated with conservative assumptions, yet even the most cautious projections indicated that some subsystems were operating perilously close to failure. Production could not pause, and so anomalies were tolerated, their risks deferred in service of output. The mountain itself seemed to fight back. Rock density varied unexpectedly along the excavation path, creating load spikes that challenged even the machine's extensive safety margins. Veins of granite required repeated passes, transferring additional strain into high-stress joints. Minor slips in the machine's footing, previously insignificant, grew cumulatively. Operators spoke of hungry ground, of sections of slope that resisted movement despite the machine's massive momentum. The terrain was alive in its own way, responding to industrial intrusion with slow, relentless opposition. Systemic warning signs multiplied in subtle ways. Boiler pressures peaked intermittently. Electrical circuits overheated under uneven load. And bearings and shafts exhibited fatigue that inspections noted but could not fully correct. Human oversight was stretched to its limit. Teams worked 12-hour shifts in rotation, continuously monitoring gauges, listening for changes in pitch, touch-testing vibrations through gloves, eyes trained for micro-deflections, imperceptible to all but the most practiced. Yet no warning could quantify the aggregate of microstress that had already spread through 6,000 tons of metal. Management recognized the anomalies, but framed them within a narrative of success. Production numbers rose, mountains fell, contracts were fulfilled. External observers, visiting engineers, and government inspectors witnessed efficiency and monumental scale. Behind the scenes, however, the arithmetic of strain accelerated. Each hour of operation added to the latent risk embedded across steel and joint, every cycle amplifying what had already been calculated as tolerable but never tested over sustained real-world operation. The escalation was invisible to those untrained, yet undeniable to those who lived with it daily. The excavator continued its relentless march, a controlled force carrying the weight of expectation and compromise. Beneath its movement, strain accumulated imperceptibly, growing stronger with every ton lifted, every slope carved, every hour survived. The mountain was no longer passive. It had become a silent adversary, and in the quiet of the operator's cabin, each worker knew the mountain was winning, one subtle deflection at a time. It began with a note too faint for alarms to register, a vibration in the bucket wheel tower, an almost inaudible click inside a bearing housing. Operators paused instinctively, sensing a shift in the machine's rhythm. Steam pressure pulsed unevenly. Hydraulic pistons hesitated for fractions of a second. The machine, vast and confident, was signaling discomfort. Within minutes, subtle anomalies compounded into visible distress. Girders flexed along untested angles. Rivets began to loosen under previously negligible forces. Noise changed pitch, tone, and rhythm, moving from background to urgent resonance. The first component to fail was minor, almost inconsequential. A hydraulic valve seized, forcing flow into redundant circuits. Operators reacted instantly, adjusting pressures, redistributing power. Yet each correction transferred stress elsewhere. The giant was a system of interdependencies. Every intervention had a ripple, and small failures cascaded into medium failures, medium into critical. By the time the bucket wheel slowed, men on the ground understood the scale of what was happening. Hundreds of tons of metal were now operating outside tolerances, suspended by ingenuity and sheer inertia. A sequence of events unfolded rapidly. Bearings overheated, steel stretched visibly along joints, creating audible cracks that cut through the machine's habitual roar. Conveyor belts jammed under uneven loads. The operator's console flickered as electrical circuits tripped and auto-reset, momentarily disorienting those coordinating manual overrides. Dust rose in clouds as fragments of rock dislodged violently, the excavator's rhythm faltering, then stuttering, then ceasing altogether. Time elongated. Observation became comprehension. Every second carried the weight of imminent disaster. Workers scrambled to safety zones pre-designated for emergencies. Some froze, caught between instinct and procedure. Engineers calculated risk in real time, measuring potential collapse zones, imagining the trajectories of massive components. The machine, once a monument to industrial triumph, now dominated the valley with threat rather than productivity. Moments previously routine became lethal. A single bucket, loaded with hundreds of tons of stone, hung at the edge of a fractured conveyor, waiting for gravity to resolve the arithmetic of failure. The collapse was gradual, relentless. Sections of the excavator shifted under redistributed stress. Girders buckled silently before loud metallic announcements of fracture. Dust, rock, and steam filled the air in a choking haze. Operators directed power away from failing subsystems, attempting stabilization. But the fundamental flaw, accumulated fatigue across interdependent systems, could not be corrected. Hours passed as the machine shuddered, convulsed, and finally surrendered its motion. The bucket wheel stopped mid-arc, a steel appendage suspended above a valley now scarred for generations. Silence followed, thick and oppressive. The valley itself seemed to exhale. Men emerged from shelters inspecting what remained, noting fractures invisible from afar. The mountain had endured, and the excavator had failed, not violently in a single instant, but through the patient arithmetic of scale, repetition, and compromise. Production ceased. Contracts froze. Observation teams documented every detail. The machine was immobile, yet its shadow remained, an enduring reminder of industrial ambition and the consequences of mechanical hubris. The aftermath rippled far beyond the valley. Production quotas collapsed immediately. Rail depots stood idle, waiting for crushed stone that would not arrive. Smelters halted, furnaces cooled, and contracts lapsed as financiers calculated the cost of lost material and delayed schedules. 6,000 tons of steel lay immobilized, a monument to both ingenuity and miscalculation. Each day of inactivity carried tangible weight, wages owed, interest accruing, penalties multiplying. Economies adjusted to absence, not presence. Industries linked to extraction experienced cascading effects. Equipment suppliers faced sudden surpluses of spare parts. Fuel contracts, predicated on continuous operation, required renegotiation. Skilled labor, once concentrated around the excavator, was either idle or hastily redeployed to smaller operations, where scale and expertise could not fully compensate for the gap. Temporary communities experienced shortages, stores ran low on supplies, medical support was strained, and social tension rose in proportion to the economic shock. The human cost mirrored the industrial one. The collapse of a machine translated directly into uncertainty for thousands of families. Investigation committees convened, yet accountability remained elusive. Engineers defended decisions based on existing knowledge, citing unavoidable variables in load distribution, terrain, and material fatigue. Contractors pointed to budget constraints and accelerated timelines imposed from above. Management emphasized production records prior to failure, framing the event as an unfortunate anomaly rather than systemic oversight. Political actors distanced themselves, acknowledging scale while avoiding responsibility. Reports emphasized lessons learned, codifying them in technical jargon that obscured human stakes, translating catastrophe into policy rather than tragedy. Reputation became currency. Companies involved in the construction of the excavator faced scrutiny, but few individuals were named. The broader industrial ecosystem absorbed shock in silence. Trade journals documented the event with analytical detachment, emphasizing numbers and timelines while marginalizing worker narratives. In parallel, insurance claims, regulatory inquiries, and corporate memos reshaped internal procedures to prevent recurrence. But the intervening months left measurable gaps in output, revenue, and credibility. In retrospect, the systemic consequences were both mechanical and social. The machine's failure highlighted vulnerabilities in the very logic that had produced it: excessive centralization of labor, over-reliance on singular systems, and the deferred recognition of latent stress. Entire policies were revised, yet human memory proved shorter than metal fatigue. The valley bore witness, both geologically and socially, to a collapse whose effects would persist long after the steel ceased moving. The consequences of scale were neither theoretical nor abstract. They were measured in dollars, schedules, and lives, silent testimonies to the cost of industrial ambition unchecked by humility. Decades passed. The excavator remained where it had ceased motion, its massive form slowly surrendering to the elements. Rain corroded steel, steam vents became conduits for moss and small trees, and the valley itself began to reclaim its scarred contours. Tracks, once aligned with precision, twisted under uneven settlement. Rivets loosened, beams sagged, and the machine took on the appearance of a monument rather than a tool, both awe-inspiring and cautionary. Its shadow lingered long after daily operations had vanished, a ghost of ambition measured in tons rather than years. Local communities adapted around its absence. Families once dependent on its schedules diversified livelihoods. The temporary towns dissipated, leaving only the faintest traces of infrastructure and memory. Engineers and managers moved on to other projects, their records stored in archives rarely consulted. The machine became a story told in fragments. Technical manuals cited for historical reference, photographs studied for lessons in scale and consequence. Yet the human cost, the daily negotiation with relentless steel, remained largely unrecorded outside first-hand accounts, fading with each passing generation. Industrial memory proved selective. The excavator's failure entered textbooks as a cautionary example of stress accumulation, fatigue, and miscalculated scale. Policy reforms cited it abstractly, focusing on safety margins, redundancy, and monitoring protocols. Public fascination, however, concentrated on its size and audacity. Headlines emphasized the 6,000 tons, the mountain carved, and the spectacle of engineering. The lesson of human labor, of vigilance deferred, of risk embedded invisibly in success, was less frequently recounted. The machine's legacy became a dual narrative, one of achievement, the other of absence. Geologically, the scars remained. And valleys retained unnatural contours. Rock faces carried the marks of bucket wheels and conveyor paths. Nature regenerated around the damage, yet the rhythm imposed by human ambition had permanently altered drainage, slope, and soil composition. Environmental cycles adapted to industrial interference, a subtle testament to the machine's capacity to reshape both matter and time. Even as rust spread, the valley itself carried memory, recorded in displaced stone, compressed earth, and the absence of trees that had once stood in the way. Ultimately, the excavator's legacy was not measured in operation or output, but in its enduring presence and disappearance. It became a mirror of industrial ambition, grand, precise, and morally weighty, yet incapable of infinite endurance. Lessons persisted in engineering halls, in archives, in whispered accounts among workers, and in the valley that had been carved and abandoned. Its silence was absolute, yet heavy with unspoken truth. Scale can overwhelm mastery, and even the most meticulous design cannot forestall the slow, persistent arithmetic of consequence. The machine remained both achievement and warning, monument and absence, iron testimony to ambition's reach and limitation, eternal in its vanishing.